So hey guys, welcome back to Pinkman Solution. And from today onwards, I'm gonna start this new lecture series on Black Hat or Offensive Go, in which I'll be showing you how you can design or make your own um, security tooling, do your own security tooling in Go language. So before starting this video, I'm just want to make sure that we are all on the same page. So for that, what I need the I just want to list the prerequisite for this lecture series. So first of all, in order to follow these videos, you need to have a good, not good, at least some basic understanding of the Go syntax. So if you're not familiar with the Go syntax, stop this video right now. Go to the golang.org website, learn this basic syntax from there, or watch YouTube videos or tutorial, whatnot. It's up to you. My point is just that you should know basic Go syntax. So once that is done, then come back to this video and start watching. So big disclaimer, if you're not familiar with the Golang, this video is not about the Go syntax or anything. This video is just about how to build upon your basic Golang knowledge and build security tools or hacking tools for your purpose. So, so in this video, I'm going to particularly focus on the port scanner, which is the most a, a basic tool you can write in Golang. So what this port scanner will do is will specify some port for the tool to scan, and that our script will run and scan that port and check whether that port is open on the remote host or not. If the port is open, it should give some log on the console saying that port is open or a connection successful, something like that. So in this video, we are going to design three port scanners. One will be a simple port scanner to build upon, which will only scan a single port. Then we'll go ahead and implement a second port scanner, which will scan the range of ports, which will give programmatically. And the third is the port scanner, which will uh, do the port scanning concurrently. So why we are using Go is that one of the main reasons of choosing Go for the offensive programming is that Go has something known as Go routines, which can do concurrent execution. Uh, so we want to use the maximum features of Go, so that's why we are here. So without any further ado, let's start. So one more thing I want to mention, if you don't have Golang or some editor installed on your laptop or system, whatever you are using, just go ahead and do Google search how to install Golang or anything, and the code editor, whatever you want to use. I'm gonna use the VS Code, which is already set up on my system, so I'm not gonna waste your time on showing the setup. You can easily do a Google search and go ahead. And so yeah, let's start. So first I'm gonna cd to my folder bhg. Bhg stands for Black Hat Go. So I'm also referring the book for this video. The book I'm referring is Black Hat Go. So yeah, if you want, you can follow along and also read the book. But I'm gonna explain line by line what each uh, line is doing in this video series, so that you can implement your own tools easily and for your use cases, of course. So yeah. So now I'm just gonna open my VS Code. Okay, so this is a start screen. So inside this folder, I'll create a new file. We'll say port scanner. Very innovative. So if you know the Go syntax, we'll start with a package main as a first line, and then we'll import some packages like FUMT or FMT, whatever you wanna call it. And one more which we're gonna use is net, which will help us to make network calls. Now we'll define the main function. Inside this, what we're gonna do, we're gonna use a net library. and call a dial method on that. So this dial function, what will do, as you can see from the prompt here, it will accept a network string which is of type address string, net connection error. Oh, sorry. So the first argument will be the type of network, um, a protocol you want to use, like TCP, UDP, Unix, and whatnot, IPv4. So you can use the TCP, UDP, or the other layer 4 protocols also. It's up to you. Next, in the second argument, we'll specify the address string. And note the address string will contain both the host and the port. So let's start. So we'll specify TCP. TCP is reliable, that's why we are using it. And we want to check whether port 80 is open on TCP or not. So scan. So for the host, I'm using the scanme nmap.org host, which is free for anyone to test the port scanning application or anything like that. So I'm using nmap.org, scanme.nmap.org. And now, if you notice here, I have two variables. One is the placeholder for which I don't want to do anything, and next is the error. So now I'll check if error is equal to nil, which means there is no error, which means that our connection was successful and the port is indeed open. So I'm gonna simply printf to printf a port ened port open. Oops, one sec, slash n, and then I'll say port is 80. Right. We could have simply placed the string 80 here, but just for generality, like we'll implement other port scanner also, I'm just giving as an integer argument to the printf function. Now it's done. So this is your first very own simple port scanner, which will scan a port on a remote host. So to run, you just simply do go run port scanner. As you can see, we get port open 80. So that was the simple port scanner, which will do port scanning only for a single port. So now let's implement another port scanner for range. Let's say port scanner range.go. So I'll quickly write down the same boilerplate. Func main. Okay, so now we want to scan a range of ports. So for that, what we can do, we can simply use the old port scanner and do all these things in a for loop, which is very simple. What you need to do is just simply create a for loop for I equal to 1, and then I less than I less than equal to 1024. You can give any port range, it is up to you. For now, I'm just saying 1 to 1000, and then I'll simply do the same stuff which I did earlier. At this time, I'm gonna specify address in a variable for each iteration. For that, I'm gonna use sprintf function. Mm, okay. So for this, I'm gonna say scanme.nmap.org, and for the port, I'm gonna say D. D will be replaced by our integer which we will specify as a second argument, which will be our I, right? So what this function is doing is it's simply saying that create a string using this format string. So the address variable will contain a string scanme.nmap.org colon and the R port number, which will be one in the first iteration and so on. So now that we have the address to scan, we'll simply do the same thing. Error, oh sorry, net.dial, and inside this we'll again specify the protocol, which is TCP, then the address string. Now we need to check if error is not equal to nil, which means there is some error. So in that case, we'll simply continue, which means the port is not open. So we'll ignore this part and just continue with our scanning. Port is closed, maybe, and outside it will simply close the connection. Okay, so you can avoid this step connection dot close because it is not required. We just want to see if the connection is successful. We will say the port is open. If the connection is not successful, we can simply ignore it. So this is just to be nicer to the server or the scan map, scanme.nmap.org host. So if you do it, it's better. If you don't do it, it's up to you. Sometimes the firewall may be configured in this way that if there are so many uh, open ports, open connections from a single host, then it may trigger alarm. So in that case, you might want to do this. So it's up to you. Next, we'll simply say println, printf, sorry, uh, port opened percentage %t slash n, and here we'll give our port which is open on the remote host. So I see some error here. Let's see, expected boolean or range of expression. Hmm. Missing parentheses. Okay, so here I miss semicolon, and this I think should be in caps. Yeah. So now I'll simply run the script, go run port scanner range. So now what is happening here is our script is going through each of the ports from 1 to 1024 and doing a network connection. If it is successful, it will say port is open. So now if you notice, this can be very time consuming for any security researcher or a hacker, or if a white hat testing you are doing on some host. So to avoid this, we'll create a third port scanner which will leverage the go routines go routines feature of Golang. So as you can see, we are only through 80 port 80 until now, which is very slow for our use case, which might be slow for your use case also. So we'll just stop this here, and now let's create a third version of port scanner. Port scanner concurrent concurrent.go. So let's write the same or I'll just copy the boilerplate from here. Just to be consistent, I'll place space here. So now to create a concurrent port scanner, we'll need something called wait group. So the function of wait group is like this. It will wait for the particular value to be 0. Until that, it won't let the program to exit. So if I run the go routine directly without the wait group, our program will uh, go through the loop for each iteration and call the go routine, and don't wait for the go routine to complete. So in that way, we won't see any output on the screen. For that reason, I'll show you first, then you will understand in more detail. So same thing, I'll create a loop. One second, I'll just copy the same code here. So now what we want to do is we want to create a new function inside this loop, new go routine called go func, and it will take one integer f, j, I'll say j of type int, and then inside the braces, what it will do, it will simply, so if you notice, this function is called an IFI. IFI means immediately invoked function expression. So I'm creating a function here and immediately calling it. So that's why it is called IFI, immediately invoked function expression. So what I'm doing is inside this loop, for each iteration, I'm calling this coroutine with this parameter I, which will be passed to this j parameter value, and then we'll say scan this. So now if I run this, we won't see any output on the screen because of the same reasons which I mentioned earlier, that our program won't wait for this connection to complete. It will simply execute these coroutines and exit. So to just show you, tap for and then tap. Yeah, I think there is some error. Continue is not enforced. Okay, so we can ignore this. So now if I run this, we should not see any output, because the go routines are because our program is so fast, it will complete so fast that it won't get any chance to complete the connection and get any response. See, it went inside this loop, called this go routine 1000 times, 1024 times, and then it didn't wait for this string to appear. It should be j actually, sorry for the typo. So now what we'll do is we'll add something called wait group. So the function of wait group is to wait on some particular value to be 0. Until that, it won't exit the program. So to use a wait, what we call wait group, will simply initialize a variable wait group of type sync dot. And if you notice, the sync library is already added without me adding it manually. This is because of the Golang extension which I have installed on my VS Code setup. So that is why if it is not happening for you, you need to add it manually or install the same extension for your uh, editor setup. So now the wait group is initialized. So what we'll do is, for I think we need to initialize it outside. Yeah, we don't want to create a new wait group for each iteration. We just need one. So here what we'll do is we'll do wait group dot add. So what add will do is it will add one value to this wait group variable. Means uh, for each iteration we are adding a value of 1 to this wait group variable, and outside the loop we'll say outside the loop and inside the main we'll say wg dot wait. So what wait function will do is it will check if the value uh, for this wait group variable is 0, then only exit. Until that, it will block the process. It will wait for it to become 0. So, and in the meanwhile, all these Go routines will run concurrently. And there is a difference between concurrent and parallel execution. If you're not sure, you can just go on Google and search about a concurrent versus parallel execution. You will get some idea. So that is done. And one more thing I want to add here is I want to defer the wg.done part here. So with this wait group.done, we are saying once this go routine is finished, we want to decrement the value by 1. A done means to decrement value by 1. Add means whatever integer we pass, that value will be added to this wait group variable. So once this go routine complete, we are subtracting value 1 from this wait group. And once all the go routines are completed, it will eventually become 0 and our program will exit safely. And all these operation wait group dot add and wait group done wait are done in a thread safe manner by the sync library. So you don't need to worry about any synchronization issues. Now I'll simply run my third port scanner concurrent. So now you'll notice how fast it is. Okay, so I've got some error here. Let's debug it. Panic, invalid memory address, null time segmentation violation at line 20. Let's see what we have on line 20. I think this connection dot close is causing some issue. We'll simply ignore the connection string for now and see whether it fixes our issue or not. Did you see how fast this is? Literally, this is, I can't even imagine this is so fast. So that's where the Golang shines. So that's why it is used by many security research for developing the testing tooling for security related stuff. So I hope you can appreciate the power of Go. Oh man, this is so fast. All the ports scanned in just seconds. I hope you can compare this with the simple port scanner with range, how incredibly fast this is. So that's all for this lecture. I hope you learned something out of it and stay tuned for more videos like this on Black Hat Go or Offensive Go series. We'll have more videos like this and slowly we'll develop more advanced tools using Go and see where it goes. So yeah, thanks for watching. Bye bye.